continuous integration. This is one of the things you're going to want to think about from the start. You're going to be wanting to work on more or less immediately to get the requisite infrastructure set up. And I wanted to therefore talk with you in a little bit more detail about what I'm expecting from you. So time was, ladies and gentlemen, that the way programs were done when I was a young man, I think maybe the world was still cooling then. We had, I think I was working with ones and zeros back then. Someone like Gordon McCullough was only working with zeros. No, I was. We were doing development, and we were doing development languages like C, and often the modus operandi for a large project was that you would aim at a set of requirements, elicited using techniques we'll be talking about later today, and you would try to build those requirements in, and a bunch of different people will be working on different pieces of the system. And then before a demo or before a build date where you're going to release it, you would integrate together their changes. And these changes might have been worked on for a period of a month or a couple weeks before they were integrated. Now that caused major problems. Can anyone tell me what are some of the major problems that come up in that context? The so-called Big Bang approach, where you're working on things for a couple of weeks, you're working on your piece, they're working on their pieces, you're humming along, and then it's time to make the donuts, to put them all together, maybe even show the client the demo. What's the problem with that? Yes?
You may have assumptions about the other side of the development that are not true, and you've been building around those assumptions for several weeks, and then all of a sudden,
boom.
Yeah.
So you have a lot of problematic issues may have been built up during that time. Number of weeks, you've written a lot of code, made some design decisions, and those are incompatible maybe with someone else's decisions. Maybe each of you made assumptions are perfectly reasonable, but they're different, right? So that's one issue. What's another issue with it? It's a bad sign when the projector is louder than the students. So speed. What's another problem with putting all those things together? What else could you imagine is going wrong? What would your fear be if you've been working on things for 3 weeks and someone else has been working for 3 weeks? You try to put together your code. Tell me some of your fears about what would happen. Yeah.
Well, you also could have like completely duplicated some things.
Yeah. You might not have realized that they were working on the same stuff you were. And you did a lot of work on it, they did a lot of work. You may think this is implausible. Happened this class last year on an area of about a week. They were working on their stuff independently, and one discovered the other had done all of that work. It was like, I don't know, 10 or 15 hours of work. Thrown away. Cast into the winds. So what's another problem that comes about? Yeah. Right, okay. So this gets to the issue, nice, Jonas, it gets the issue of debugging, for example. A lot of things have changed during that time. You put them together, and the Big Bang often yields big problems. And where are the problems coming from? Well, a lot has changed during that time. A lot of changes have occurred. And to track down where exactly the problem's originating often requires a lot of effort, therefore. Imagine if you had just checked things in 2 hours, you had each been working on it for 2 hours. Well, there's only so much that changed during that time. And if it now doesn't work, and it worked 2 hours ago, then you have a much smaller set of things to look at. Over 3 weeks' time, 2 months, That's a lot bigger of an issue. These are not minor things. These were things that would bring sometimes companies' products to their knees. They would go months with people working on different parts of this. Think about something like the Office suite, Microsoft Office. One person working on Excel, this part of Excel, the printing features, this other piece of Excel having to do with the recalc engine, other piece, macro components. And think about other people working with Word and with PowerPoint or whatever. And all those have to come together at the end. They have to work together seamlessly. You want to be able to paste the table from one to the other. And you have these teams that have been working more or less independently, you bring them together, boom, blows up. These cause big problems. And actually, Microsoft was, partly because of these sort of problems that were manifested, they were one of the first to evolve this technique I'll just be talking about. It's documented in a book called Microsoft Secrets by Cusimano. It has a quite articulated description. And at that time it was called daily build. Now it's morphed into what we know as continuous integration. Can anyone tell me when I say continuous integration, what do I mean?
Well, people should constantly be submitting what they have done so that it can be all put together on a continuous basis so that you can have these massive parts.
That's right. So maybe a couple even times a day, they're checking in a new piece. So they go, they finish their work of small pieces, and they check that thing into the code base after going through some basic processes we'll be talking about. And then that's shared with other people, so other people get the results of their work. And a key part of this is that people are expected to refresh their code. Not necessarily check in every day, but at least refresh their code every day. Get a new copy of other people's code. To prevent this issue that you're going to wait a week and then suddenly get all these things which break your code or which duplicate your code. Okay? So we're doing this on an ongoing basis, a continuous basis. People have argued that this is sort of the Project Heartbeat or Sync Pulse is kind of ongoing refreshing going on. And there's something else that accompanies this besides simply checking in. And that is the fact that when you check in, ladies and gentlemen, you are, moreover, triggering a process of a build. And that build involves compilation and linking. So taking your code, compiling it, linking it together to a full program, potentially running a set of other things like stylistic checks, like a set of unit tests that exercise it, and something called a smoke test. And ladies and gentlemen, each of your teams will be required to implement a smoke test. Okay? We'll be talking about this. This is a system-wide test of basic functionality. It helps make sure that when you've checked in your code, you're not so hosing the system that when other people refresh, they're going to get terribly messed up. They're going to get a system which is really lousy. Now, Microsoft's initial adoption of this involved what was called a daily build, and typically got into very much a daily process. Every night they would go and build the system, and you would refresh in the morning. As long as that build worked, you'd get a new set of code. If it didn't work last night, if the build failed, then you wouldn't refresh because you would wait until it's fixed. Whoever checked it in would have to go fix it. If someone's check-in caused lots of compilation errors, they would need to fix that before you wanted to refresh. And continuous integration takes us even to a larger level, and it harnesses the fact that our machines now are much more powerful, and therefore, when we check things in, every time someone checks something in, we can do a build. We can do the compilation, we can do the style checking, we can do the testing, etc. We can do the distribution, we can rebuild the databases, etc. Okay? So with continuous integration here, the build is triggered by all developer check-ins. And it can allow for pinpointing problems to particular check-ins. Not just any problem that came by during this day, but any code change that occurred during this day is responsible, but this can tie it down to a particular check-in. The system was working, the smoke test worked before this check-in, and after it didn't work, and you can go do a diff, SVN diff. People comfortable with that? SVN diff? Yeah, okay. You can use that to figure out sort of what changed here, right? And continuous integration is best practice widely used in the industry. It can be challenging for larger projects, but has some huge advantages associated with that. Cooperation help reduce this integration headache. Quicker identification of the sorts of problems. Helps identify the current state of the process. You kind of see where you're at after this build takes place. Allows you to do better estimation, how far along we are, how long it will be to fix it. Reduces the need for status reports. You don't have to go ask someone, where are you at in your implementation of X, Y, or Z, because they're checking in enough, you kind of see them coming along, their various pieces, sub-pieces of it. It can improve the team morale, because you're actually seeing the system come together. And importantly, ladies and gentlemen, it helps force developers to fix bugs before continuing. There's an expectation here, before you do further development, you're going to fix bugs associated with your pieces of the system. Okay? Fix your bugs, you clean up things before you go and try to do more. You finish the tasks assigned to you in terms of bugs before you're doing the fun thing of implementing new features. So there's generally rules governing bug fixing versus new development, and there's sort of this expectation that fixing bugs should be the top priority. If you have a feature where there's a bug and a new feature you want to implement, you fix that feature first. Okay. So I want to talk about some aspects of how this works. The idea here is the developers typically work in their private sandboxes. They have this working directory with SVN, right? So we have a repository, and then we have this working directory, and we're going to be doing SVN updates in that working directory. Am I talking a language people understand? If I said SVN update, what does an SVN update do? Yeah. So it gets the latest changes from the state of the repository for the particular window of that repository, say the trunk that you're working on in this particular working directory. So maybe you're working on the trunk of the system, the kind of main branch of the system, and you're going to be periodically doing this SVN update and get other people's changes that they've checked in, right? So someone else out there updated display.java, and you're going to get the latest version of display.java because you've done SVN update, right? You're going to be doing those refreshes every day at the least. Let me restate that. This is highly testable. You're expected to refresh your code base in your private directory at least once a day, okay? So that you get other people's changes. So instead of getting everyone's batched up changes that have occurred over the last week, you get them that have occurred in the past day, or even better yet, the past few hours. You're just getting constantly resynced with everyone else. You're getting on the same page in line with everyone else, okay? So you're working a private sandbox. You've checked out the code from the repository, SVN checkout. You're working there, and you do SVN updates periodically, okay? You'll note that if the build breaks at some point, if there's a problem with the build, if someone's checked something in and now it can't compile, right? Or now it can't run the unit test, or the smoke test fails, you're not going to want to do an SVN update. You're going to be getting a warning, typically automated, from the build server saying the build is broken. Because you don't want to get that code down to your system, because then you won't be able to compile. So you'll get notifications if there's a broken build. So you want the code from the last stable build. Now, these builds are best done from scratch on the build server. So the server, the person who maintains the build server, so-called build master, should be setting it up so it runs it from scratch. It recompiles everything and links them together and tries running the test. Why do we build it from scratch? Can anyone say? Oh, what's the alternative to build from scratch? If I was using make, what would I say if I wanted to build it from scratch? You folks have taken 214, so you should know this. If I'm using make, and I have a make file, what would I use to build something from scratch? What 2 commands? What would be the first command? Make clean. So I get rid of all the existing code, make clean, and then what do? Make all. Okay? Make clean. What's the function of make clean? Does it use soap and water and scrub it? Yeah. So it's all the existing objects, all the derived files, all the files that have been created by the build are cleaned away, right? Starts from scratch, and then we do a make all, and it builds everything. Why do we do that? Why don't we want to start with the existing object files? Yeah.
We don't have a guarantee that the existing object files were updated at the source level, and the object files we already have are outdated.
Yeah, it could be that the files that we have are out of date. It could, further, it turns out that there are sometimes issues when you link, that will show up when you do a completely new build that will be hidden otherwise, if you're just operating from those existing object files. And the fundamental thing is you're not really having this in a it's not reproducible, ladies and gentlemen, unless you start from a common reference point. You want to be able to see bugs, and to have those bugs be reproducible, you want to start from a common reference point. You're not working off of object files that from different dates at different times. You want to start from scratch, build it from the ground up, and avoid possible situations where the manifestation of a bug will be hidden because you're using more recent object files for something. It may sound unnecessary, but believe me, sometimes these things happen when making the system. Okay. Secondly, they test their code against the most recent checks. Developers test. So if you're developing some code, say for the login module, you'll be operating your code. When you're testing your code in your own little sandbox, your own little working directory, you'll be testing it, ladies and gentlemen, against the latest updates from other people before you check yours in. Before, right? You get their updates. Before you go to check it, you do an update, you recompile, and you make sure things work before you check in. You don't want someone to update their code a few minutes before yours in a way that's incompatible with yours. You check yours in without checking, and now other people can't use the system. Right? Generally speaking, this daily build is going to be going on, but you're not going to pass it to customers. You're not going to pass it to Dr. Bazran, the results of your daily build. You're going to do that at defined points where you've done really rigorous testing and you're sure it's workable. This is going to be keeping the system constantly runnable. So that's good, but the runnability is not going to be typically, you're not going to pass the runnable elements of it to outside stakeholders. Now, generally maintaining the daily build is a full-time job in real-life projects, and in this class, certainly at least for many periods of the class, it may be a more or less full-time job. Why? What is the build master doing? Can anyone tell me? What jobs do they have to take?
Let's see. From my understanding, they'll be making sure that the current the current stuff in the SVN repository will be somewhat stable. So if someone does wind up committing something that just breaks everything, they'll make sure that that they can revert it back to a stable build.
That's right. So they have to respond quickly if someone's broken the build. Often there's an automated message. Typically there's an automated message which will be sent out to people saying the build failed. Okay, but they may have to be involved manually in rolling it back. Yeah, Joe.
They'll also be working with the testing team to make sure the tests will be, the testing suite is up to date and everything.
Bingo. This is one of the biggest things they're involved in. They're going to need to update their test suite on the build server. They're going to get, you know, who's going to write the unit tests? Who's that? Who's writing the unit tests in this class in your teams? Well, some, but mostly unit tests should be written by whom? Developers. Have you ever heard of test-driven development, folks?
Yeah.
Write your test before write the code. That means developers write actually the bulk of the unit tests. What are testers writing then? They're writing system tests. They're writing tests often that tests several phases of the system, but not just system tests. They're also writing integration tests to make sure A plays with B nicely, that those two work together. They're writing some unit tests, but mostly in development professionally, unit tests are mostly written by developers. Now, if developers don't write their unit tests, well, maybe you should hit them with a wet noodle first, but you should make sure they do from now on, but then the tester might step in. But unit tests, a lot of the unit tests, most of the unit tests should be written by developers in this class and in industry. So those are some tasks for a build master. What else might a build master do? Besides running suites of unit tests or other tests passed on by developers, that's key. They're also working on something called the smoke test. We'll talk about that in just a minute, okay? They're also working on scripts which would do other things during the build, like run a style checker. Maybe it would do, in some cases, even coverage testing, although that's unlikely. Possibly it will set things up so that it could go and do sort of extra levels of testing using tools like lint, which basically make sure the program isn't exhibiting any real warning signs in terms of using risky components, doing something that may be an assignment to a null variable or what have you, through a null variable, dereferencing a null variable. So they're often involved in script development. This is actually a key thing. With Make or with, so how many people here have used Make? Okay, good. Most people. What's a common alternative to Make for Java development? Actually, several. What's one of the most common ones? What's that? Yes, that's right. So, T. And you may want to use that. Maven is a very, very popular tool as well. These are easier to maintain, in some ways less cryptic than Make. Make can get pretty odd, you know, it distinguishes between spaces versus tabs for indentation. It's quite picky for that. Ant is one based on XML. It's much nicer, very popular in the Java world. And developing those scripts, whether it's a make file or whether it's an Ant script, these things take time. Remember, people are adding modules to this system over time, right? Someone adds in a module, and the build master needs to make sure that whatever on the build machine is taking into account all these different modules. So they're going to be developing these scripts, often in conjunction with the developer. The developer adds a new .java file or .c file, whatever it is, and the build master needs to probably talk with the developer and ask, does this need to be built with any special command line options? Is there anything unusual about this? What depends on it? That sort of stuff. Right? There's for this to run smoothly, there's typically a culture which requires check-ins at least every few days. Notice, I didn't say every day. What is done at least once a day? Updates. Checking in should be done at least every few days, hopefully every day, maybe even several times a day. Why do I give more slack for that? Why not just say it has to be done every day? Yeah.
Yeah,
sometimes you're working on a tricky algorithm, and it takes you a day or two just to get it right, and then you've got to have a bunch of debugging and maybe write some further tests associated with it, and develop confidence, maybe have it peer reviewed. You don't want to force people to check in every day, because that's basically unrealistic in terms of them assuming they're going to get their work done in a day, and that can't always be done in a day. Some things take longer. Why do we refresh our code every day? Well, the burden is less. I mean, it's quite straightforward for us to refresh our code. That doesn't require too much on our part, and there's lots of other people who might have checked in during that time, so we may get other people's code during it. Okay, so they've done their SVN commits, we do our SVN updates, and we get their changes. Does that make sense, ladies and gentlemen? Does this notion make sense? This may seem weird rituals, but it's not. If you neglect these things, you're really at risk, folks. You're at risk of just causing yourself a lot of extra time debugging, a lot of extra time getting your system to a point where it can even compile after you've done an SVN update. You want to do these things on a regular basis, okay? The Buildmaster is responsible for maintaining pieces of this. They're going to be involved in working with the testing folks to create a good smoke test, something that exercises the system enough to have some confidence that basically things are sane. They're basically working. I should note that, and we'll come back to this, that the people are responsible for doing private smoke testing before checking it. So let's talk about the smoke test. So what is the smoke test? Well, the issue here, ladies and gentlemen, has to do with the fact that when we're working with a team, people are going to be contributing code. People are going to be contributing code on an ongoing basis, right? True or not? True. And when they contribute code, we want to have confidence that that code is meaningful, is not going to cause us problems before we refresh, right? Imagine if every time I refresh, I find I can no longer compile, right? Because the code that was checked in, it worked on their machine, but they didn't, my machine is something different, or more to the point that that it was making certain, it had certain broken things in it that they didn't even check to do a compile before checking it in. So it can't even compile. Or maybe it compiles, but it can't link in. It can't be linked together with other elements of the system, other .class files, for example, in Java. These are possibilities, but another possibility is that code that they've checked in messes up the system in a deep way, in a way that would get in the way of other people, including my own work. How could someone else, suppose I'm working on the printing functionality for cement. I'm working on printing functionality, print out information related to this systematic review app that Cheryl Walden talked about last time. How could, if I'm working the printing side of that, so I want to be able to maybe print out a little report of how many articles were examined at each stage or considered at each stage, why would my ability to work on that be affected by other people's check-ins? Give me a scenario. Yeah.
Let's say someone changed the way that the data was stored for the stuff you were printing.
Yeah. Okay, suddenly my code might not work, right? So that's true. So that's a good example. Something about data storage. They might not have coordinated with me, and my code still depends on this other format, and suddenly my code breaks, right? What's another reason that my code might fail? Give me a sort of thing, like what's the worst case that could happen? You do a refresh, it compiles all fine, get a nice thing to run. You have your jar files packed up, and you go to run them, and then what happens? Yeah, it's say faults when you start. You can't even get to your printing point. Or maybe you can't even load a document in, or you can't load it, you can't reload the systematic review you were in the middle of. You can't load in the test cases, what have you. It's hosed the system. The system no longer works enough for me to get even to printing. Could that happen? Yeah, big time. In other words, it's not merely compilation errors, folks. It's not merely errors in going from .o files to an executable. It's not merely errors which show up when I say, Java, I call the JVM to run with these .class files or these jar files. The issue might not show up until I'm actually running the application. And now I can't do basic things. Every time I try to load in a document or every time I try to log in, I can't even get in. Could that get in the way of me testing the print functionality? Big time. And that could happen for a lot of people working on different pieces of the system. Suddenly, the basic system is hosed. And they are screwed. They can't do their work anymore. So, ladies and gentlemen, we count it as a failed build. We say the build has failed if it fails compilation, for sure. If it fails linking, ability to fire up Java with the class.class files or the jar files. That breaks the build too. But we also call it a broken build if the system is basically hosed. The basic functionality is broken. Does that make sense? So the question then becomes, well, how do we test if the basic functionality of the system is hosed? How are we going to know if when Joe checked in his latest changes, maybe it all built fine, maybe it all linked fine, maybe we can run the system, we can start it up, but it crashes immediately, or you can't even log in. How are we going to know? Well, you need to write a smoke test. That's what the smoke test does. The smoke test basically makes sure the basic functions are working. Now, that's kind of a loosey-goosey definition. What do I mean by basic functions? Well, that's something the build master has to figure out with the testing. Have to figure out, okay, what are we going to test in this smoke test? I'll tell you this, it's going to be imperfect, because all testing is imperfect. I'll tell you this further thing, that if you do it, there'll be less risk than not doing it at all. At least test. I mean, if you have a web-based system, at least test, that requires a password, at least test you can log in, right? If you have a system on a handheld, at least make sure you can fire it up and it doesn't crash immediately. And it's typically a system-wide test, so it's an end-to-end test. It's like a use case. The user comes, they open it up, they open this file, they make this change, they request such and such, and then they close it down. Does that work? Does that basic sequence, which used to work? If so, we declare it as having passed the smoke test. Again, it's imperfect, but it lowers your risk. Because if that doesn't work, if as soon as you fire it up it crashes, or if it corrupts the data, so you can't even undertake a step in it, you want to know about that before you refresh your code. True or not? So the smoke test, ladies and gentlemen, is really important. And it's missed on the final exam by a lot of students. The smoke test is a different sort of test than many others, in the sense that it is to determine if the build is, if the check-in is successful, if the build is broken. It's part of the daily build. And why does it do it? It's to prevent you from getting screwed over by someone else's check-in. By a check-in which breaks the system, even though it still compiles, even though it still links, the system is now so badly broken you can't do your job. And other people on the team cannot do their job. Does that make sense? Speak youths, as if in a Greek chorus. do you not understand why the daily build exists? Thank you. I like that Greek chorus. A fine rendition. So the smoke test here is this test. Its job isn't specifically like other tests. It's not. Most other tests are designed specifically to discover new bugs, probe whether this part of the system is working properly. Here we're basically identifying stability problems. We're seeing, are these basic features which have been working still working? Because if so, we don't want any part of that new check-in, and whoever did that check-in has to go fix it. Okay? Because if we get those changes, we may not be able to do our job anymore. And it's going to cause a lot of pain for a lot of people. So that, ladies and gentlemen, is the smoke test. So this notion of breaking the build, making a check-in which doesn't compile, compiles but doesn't link, which has really lousy style associated with it, which hoses the system so other people can't do the job. All of those are elements of breaking the build. And it's very important that this be an exception and not the rule. So you want to be able to reliably pass the smoke test under this. And this is tough under pressure. You need cultural pressure against cutting corners. And different teams do this differently. But the fundamental thing you want to prevent happening is people checking things in that are half-baked, that haven't been fully tested. And one of the biggest dangers here, mark my words, folks, this is true in industry and it's true in 371, maybe even more so. One of the biggest dangers here is you do your check-in before updating your code. In other words, getting other people's changes and recompiling. You've got to do that because that code's on the server now. That's part of the repository. If someone else gets your code, it'll be with that new code. So your code sure as heck got to work with this other code. So you've got to do a refresh, rebuild, testing on your own machine. You want to run the smoke test on your machine. Does that make sense? You want to run the smoke test before checking in, because if you don't, you're not going to know if it's broken. And the only way you're going to know is if you've checked it in already and it breaks there. So you might as well do it on your own machine. And you're going to want to do basic testing on your code. Make sure it's all basically okay. So you need this kind of culture build up that, hey, when we go and check something in, when we do an SVN commit, this is a serious thing. This isn't to be taken lightly. We're talking here about possible wasting of other people's time. So if we're going to check something in, we want to check something in that has quality associated with it. Is that understood? Okay. That's good. And I have to say that a lot of teams in 371 have done a good job with this. But inevitably, a couple times this semester, there's going to be some broken builds. Ladies and gentlemen, later in the semester, we're going to be talking some about a systemic view of software products to help us understand how all these pieces fit together. And one of the things we'll be talking about there is dealing with the symptoms versus dealing with the cause. Trying to fix something in a way that merely is addressing the symptoms and not the underlying cause versus really fixing it by addressing the underlying cause. I will tell you a story of a team some years ago. One of the developers in the team is now at Apple. Claims this class was a key turning point in his career. He was on that team, and it was a large number, and they had problems because people were checking things in prematurely, and it was breaking the build. So what did they do initially? They made it so that they disabled the messages sent about broken bills. So they made it so when they broke the bill, it wouldn't bother them about it. And they didn't get very far with that. They're dealing with the symptom, which they found annoying, that they were getting all these messages about broken bills. Instead of dealing with the cause, was the fact that people weren't adhering to this guidelines, to these principles of checking things in that are about which they have good reason to believe they're quality things. And as a result, you know, they've missed opportunities to straighten out the situation and it worsened. Let me ask this though, folks. Suppose you have two great developers, upright citizens, fine people who even under pressure do a good job. They do a refresh of their code base, they run their unit tests again, they compile, do whatever linking's required. They run their test cases again, they run the smoke test, things are hunky-dory, things are all good, and then they check in only after that. Maybe they've even had their code peer reviewed. Maybe they've had it all documented, and they do a check-in. So suppose we have a team composed of 2 people like that. Could the build still be broken? Is it possible a broken build could still occur? So I see some nod and some heads nodding. So why is that? That's right, but wouldn't so I'll play devil's advocate. Okay, so you've got the right idea. But suppose I'm upright developer A, upstanding developer A, and shouldn't I be able to catch that by doing a refresh just before I check in? In other words, shouldn't I get all the changes from developer B and see that it doesn't work? No? Want to run the smoke test?
I guess, but then you always have to update your internal units, right? By the time that you finish this test,
Exactly. That's exactly the vulnerability. It could be I do a SVN update, and then it takes some time to do the build, it took time to run my test, and in the meantime, they've done a check, right? And I didn't get it. You know, didn't get it in time. I checked mine in, and now it breaks the bill. It can happen. And you know, folks, I'd like to know about broken bills. I'm not gonna, you know, it's not a mark of shame or something per se. Although, if it occurs many times over, it starts to be a mark of shame. In some teams, in some companies, breaking the build is something that if you do it, especially if you do it frequently, you have to wear a hat that makes you look silly, or you have to pay $10 each time you break the build. And the fact is, you wasted people's time, by and large. And often it's a result of laziness or sloppiness or whatever. So, ladies and gentlemen, please don't break the build. Okay. I think I'll skip that. Let's just talk about key components here. So the idea here is we're running this build on a server, and the server is connected to SVN, and every time there's a check-in, it wakes up and it does the build. And I've listed in the syllabus quite a large number of different systems that will support this. So Hudson and Jenkins and Cruise Control, and there's a wide variety of different systems that do this. And the idea is that if the build is unsuccessful particularly, but even if the build is successful, there's feedback given. Sometimes emails are sent saying you've broken the build, or the build is broken. Actually, it's important. Who do those emails have to go to? Okay, they have to go to the build master. Who else does? If there's a failed build, who needs to know about it?
The person who checked the build.
Okay, that's absolutely key. That's the most important one. But who else needs to know about it? Think about it. Think about mechanically what's going on. Think about how these processes occur, and these descriptions of what you should be doing on a regular basis. Who needs to know if the build is broken? Everyone needs to know. Why? So they don't do SVN update until it's resolved. Right? They need to know as soon as possible, hey, stop your SVN updates because we've got a hosed situation, and until that's fixed up, don't do an SVN update. This is very important. It's also examinable. Okay, so we have these points of feedback here that occur, and there's often feedback in the form of email. So, some teams even have sort of orbs that glow red if the build is broken, or green if it's still working, or they'll have a certain sound played. One can imagine the various sounds that occur when a build is broken. Okay, so let's talk about some basic principles associated with the build. And these are written up by Duvall in a good text. So commit your code frequently, preferably at least once a day. That's what they recommend here. It's not always possible. Don't commit broken code. If you don't have great confidence your code is okay, you're threatening to waste everyone else's time. And that's not something you should be taken lightly. Fix broken builds immediately. Write automated developer tests. So verify using automated tests that the system is working. The build and the build master should be working to run a suite of tests every time things are checked in to make sure things are in good shape. Okay, all tests have to pass before committing it. This is a matter of most of them pass, so it's almost past this other one. No, make sure they pass. Run private builds before checking in, because you want to know when you do check in, you're going to mess people up, so you want to test before. And avoid getting broken code. So as it says, the build failed, you're going to lose time. You're going to be messed up if you go get the code there. So wait until the developer fixes the build failure. Okay, now on the testing team, there's a set of other ones. Automate unit tests. Ladies and gentlemen, a lot of you will have done testing by hand. Some of you will. How many people in here have used test scaffolds, also called test harnesses, before? 214, you didn't have to do automated testing? Gosh, I just taught 214 last term, and that was a big part of it. Ladies and gentlemen, I think I need to give a lecture next time about automated testing. So, how many people here have done automated testing of code before? Okay, many. When you did that automated testing of code, how did that happen? You wrote some code and it called off to tests? Is that right? You wrote code and that code called off to tests? We call that code you would have written a test harness or test scaffold, and it called off to perform test A, test B, and maybe it set things up to happen so the things were all set for the test, and then it called off to perform the test. So that's what the test scaffold does. And the idea here is to write test scaffolds so you automate unit tests, automate component tests. You have these tests just running automatically when you test things in. Okay? Unit tests are occurring on a smaller level. Component tests often test several pieces together, and then system-wide tests. Ladies and gentlemen, how would I write a system-wide test that's automated? How would I create a system-wide? I'll say, how will I create a system-wide test? Give me some possibilities. So suppose I have a web app that does this kind of thing. How am I going to test that in an automated fashion? What would I have to do? Yeah?
You'll have to systematically go through a number of conditions that could be presented for that kind of task that would be done, and make sure that the output is expected.
So I go through a set of use cases, sort of that this might be a scenario. The person goes and tries to enter the password and can't. Does it operate properly? Or does it automatically once a minute? Does they try to go enter the password, it works, and then they come in, and then they you know, they leave. Or they come in and then they open existing review and they press this button and that button and then they leave. Those are some very scenarios, right?
Yeah, and ideally you'd want to cover as many of the different possibilities.
Good. That's exactly right. So, how many people in here have seen discussion of coverage testing? Okay, you. Okay. So you want to systematically think through, like, you know, have we tested the situation where the password doesn't work? Have we tested a situation where the user, and if the user requests something that's impossible here, or they request something that is legal here? So we'll have some components on testing later in this course, but fundamentally it involves thinking through different possibilities and making sure that you hit at least some major ones of those, and preferably all if possible. And often that can be done from a high level. So the idea here is to test system-wide tests of this sort. That can be implemented. Your name? Kevin. So as Kevin was saying, to run these scenarios, that can be done often in a programmatic way. So you have a little test harness, and it says, calls off to something and it says, you know, perform login with this information. And then it says, perform sort. And then it calls off to, you know, extract maximum or something like that. So it goes through a set of stages that would be called by the UI, but it's actually not going through the UI. People understand that. So the UI on your system, you may have a UI, and I don't care whether it's an Android-based app, or I don't care if it's a website or a desktop app, desktop application. You may have, you know, some user interface, and it has fields, and you know, drop downs, and it has radio buttons, and all those good things, and it has, you know, a button that says next and back or what have you, right? Right? True or not? True. And this, to do its job, this UI should be calling off to various things. It's calling off to various methods and classes, right? Or to various functions, right? So if you say next, it will enter this information in the UIN, it will extract some other information to present to the next screen. Or maybe this says, you know, calculate or whatever in it, and it's going to do a calculation, right? So each of these things is going to tell the system by calling off to methods in various classes, you know, class A, class B. It's going to be calling off to various methods, right? And basically your automated test could call off to these things, right? It could call off and say, do this. Yes, sir. Do that. Yes, sir. And it's just as if you were going through the UI, but you're not actually going through the UI. You're just mimicking as if you were going through the UI for some common cases. People understand that. Okay, so that's one possibility. Another possibility, folks, is if you actually have tests that run through the UI. Could you have tests that actually use a browser? And click on this button and they pull down the drop down, go to this URL in a browser. Can you do that?
Yeah, I've seen it done, although not a lot.
Yes. So there's a wide variety of frameworks actually for doing this, and classes, different versions of these classes have used different frameworks. I mentioned one a few lectures ago, Water, web application testing in Ruby. It's exactly to test web applications through a UI, and JRobot's another one. There's this. I think it's Emma is another one that's used to test Java UIs, for example. So there's any number of frameworks out there, and they evolve over time. So there's frameworks that will go through the UI, and you should be thinking about those as well. What are some of the trade-offs there? It's slower, and it's also, what's another shortcoming? What's another advantage of it versus, you know, just calling off to these methods in the classes? well, here, for your test harness, to get it to call off to this one, this one, this one, in the right order and so on, you have to do some thinking, right, about what would happen here. Like, oh, well, when they press this, this method will be called when they press that. Going through the UI will actually be simulate the user experience in that sense, right? But what's the other big shortcoming? What happens to UIs? What happens to UIs at a rate much faster than, say, business logic or than the back-end database? They what? They change. UIs change. Ladies and gentlemen, it's not an exaggeration to say that much of software engineering consists of attempts of careful approaches to help isolate us, help reduce our vulnerability to change. Reduce our vulnerability to change at various points of the program. Make it easy for us to change if there are certain things that will often require change. We want flexibility with respect to those things, etc. And UIs change a lot. And some of these frameworks, particularly those years back, when they were actually testing the UI, you'd have to tell it, like, click on this pixel, or click, this many pixels in and this down and this one. It would actually do a click. It would be as if the mouse went there, just like that. Wouldn't always play that sound, but it would click, it would pull down, and then it would feed in keyboard things. And so if you move this button, you moved it down a little bit. Now the test would miss. It would be pressing there, and it would just miss the button, and so nothing would happen, and the test would fail. So now UI testers are somewhat better, and you can often specify a lot of them by saying press this button based on its name or something like that. It'll actually go press it. You don't have to say what pixel to poke it at. But UI tests break often more quickly than tests in the system. Okay. Those are some comments on testing there. If you have a database, yeah, this is important, folks. Books are innocent. Especially after some of these things are 214. But ladies and gentlemen, your application depends on a database. You should be thinking about maintaining the data in that database very carefully. Because you want your test to be reproducible. If the test fails now, it should fail later. It shouldn't depend on whether data happened to have been inserted in the database between those two times. So when tests run, they should run with respect to known conditions which are clear. And so before you run a test, often you'll clear out a database. To run on an empty database, or put data, clear it out, put new data in, it's in a known state, and you run the test. Okay? Does that make sense? And part of this, ladies and gentlemen, even if you're writing an app, or an application, a web app, or what have you, where it's using a database, each developer, when they're working on their code, should have a copy of that database so they can set it up in the way they need for their test. You don't want it to all be going to one database out there on the web. All these testers probing this database, because who knows if it's in a reproducible state. I go to run my test, and Joe may have put data into this database. He may be probing it behind the scenes, right? And now it's screwed up my testing. So you should have very well-defined databases, and when you go to run a suite of tests, they should start from a very well-defined place. And indeed, ladies and gentlemen, when you do a build from the ground up, as is typically done in the build server, if tests in the test suite are going to require the database, it needs to clean out the database, put new data into it. And often, ladies and gentlemen, in the build, it'll even, mark my words, this is one of the things which often occurs during a build, it'll actually go delete all the tables from the database, reapply a database schema from scratch. Oh gosh. How many people know what schema is? Okay. It'll reapply a database schema from scratch. Say basically build up these tables with these fields and these these constraints or whatever. We'll actually go build up those tables from scratch, then put data into them, and then run the test suites, right? So it's from, again, a known base point, a known point of reference. So, and each developer is going to have their own version of that database. So when you're looking for reproducibility, make clean here, the equivalent of make clean, may also be involved in wiping out things in your database and reconstituting it. So again, the idea of make clean, you start from a common point, a clear reference point, okay? Now, gosh, I don't know where this, I had a very nice little thing, because very few people here have seen Ant. I had a nice little Ant script in here, and it seems to have eluded me. Where's my Ant script? Alas, it's proving elusive. So I'm going to have to find that at another point. But you folks should be thinking about Ant rather than Make. Make is great, particularly for seed development, if you have smaller projects or what have you. And in your case, you should at least be thinking about Ant, maybe using Maven, Maven build tool. These things will spare yourself some trouble, and you won't have to fight with the weird arcane syntax of Make scripts. Okay, the final thing I want to talk about here is directed triage. The idea behind directed triage is that you're deliberately wading through bug reports to prioritize things, and typically we are working through reports of potential bugs within our system in a way that wouldn't allow us to fix all of them. We instead want to prioritize them. Okay, we want to prioritize which of them are most important for fixing, which of them need to be fixed for this release, and which can be deferred. And there's often a dedicated people, triage individuals, and often a triage team. Sometimes it's a dedicated triage person, sometimes it's a risk manager, sometimes it's a dev lead and test lead, who are involved in trying to figure out which of these things do we really need to fix before we give Osgood the demo tomorrow, right? You're not going to have time to fix everything. Instead, you deliberately wade through the bug reports and prioritize things and figure out, okay, where are we at? How bad is the situation right now? And which of these things are worth fixing and which are not worth fixing? Often within a team, you're going to have bug reports coming in, left and right, and it's hard to know, are those really serious things, or are those things that aren't really of great concern? Are they really minor aesthetic things, or are they really important concerns? So directed triage can basically help us understand where are we at, how bad is the situation, and it can help us prioritize which things do we actually need to fix. So what's expected of you in this general area? One or more build masters. I would suggest shadowing the build master so that someone else can step in the role in case the build master drops or gets sick or otherwise is not available. Non-negotiable, build master, one-step build. Building by hand is for the birds, folks. And you'll just not get very far with it. And in professional world, they're not going to have you do builds by hand for any serious projects. You want one-step builds where you, ideally it's, on your own system, you should be able to just type it in and boom, it recompiles things from a clean site. And I'd suggest at least using Ant. On the build machine for continuous integration, I want this automated. So when a change occurs, when something is checked into Subversion, it kicks this off, kicks off the build automatically. Boom, starts. It should be 2 a.m. It just is starting up. Okay. There should be a check-in schedule. I want you folks checking in very frequently, ideally every day, but at least every few days. There should be daily refreshes, if possible. So refresh your code base. In other words, do SVN updates. And you should be testing reliably against that refreshed code base before you check in. And that involves recompiling things, and testing, make sure it works. I want to see a build status that's available publicly, including to me. I want to be able to know, is your build broken? Is it working? When was the last build? You may want to have different release and debug versions of your system. We'll come back to that. Use of assertions gets into this. And there should be a smoke test. This smoke test is not static. It has to evolve over time. Why does the smoke test in this class, for example, have to evolve over time? Why isn't it just one thing written up front and that's it? Why is it changing? Yeah, exactly. Your application, if it's going anywhere, it's got to be adding things in. And as it grows, you want to test more and more. Again, the goal is not an exhaustive test. The test is basically make sure it's sane, but you know, as new pages get added to your website or as new elements get added to the phone app, you're going to want to test those things out. The smoke test results as part of the build status should be reflected there. And those who break the build should be able to be identified and told, hey, time to fix it. You did this check-in. It was working before that. It's not working now. You're responsible for fixing the situation. You're the one who knows what may be off, or if you want to do a rollback, that's okay. But you're the one who's responsible for doing it, so you're the one who has to fix it. Okay. Okay, so that's what's required of you in the course. Compared to teams 5 years ago or longer, your situation is better. I mean, there's lots of good tools out there for continuous integration. Research them, particularly at the build master, install them, configure them, and it's off to the races. Someone like Dylan can probably help provide advice, but there's no shortage of advice out there in the web. Okay, so that's all for today. Any questions, folks? Okay, great. So we'll continue on next time with discussion of requirements.
Yeah, we need a 4.